Before we continue factoring, let's look at the following product. 5x plus 2 times 5x minus 2. Now this is of a special form, of the form that we call a plus b times a minus b. Two things added here and the same two things subtracted. All right, when we multiply this out, we're going to use FOIL. Let's see what we get. First times first, that'll be 25x squared. Let's look at the outer product. We have a minus 10x. And the inner product, we have a plus 10x. So you see how these cancel. So they're not going to appear in the result. And then let's do last times last, and we have minus 4. So our answer is of this form. It's actually, where does the 25x squared come from? Well, it actually came from 5x times 5x. I'll write that as 5x squared. And the 4 actually came from 2 times 2, so I'm going to write that as 2 squared. So we end up with a product, with a result that is something squared minus something squared. This is called the difference of two squares. And as a general formula, we have a plus b times a minus b is equal to a squared minus b squared. Again, the middle term drops out, and we only end up with first minus last. We are going to do some factoring now where we use this backwards, and we call it a difference of two squares formula. So we're going to look at polynomials of this form, something squared minus something squared, and we're going to factor it into a plus b times a minus b. Number one, we have x squared minus 4. So let's write this as something squared minus something squared. So this is our a, and this is our b. And remember our little formula, a squared minus b squared is equal to a plus b times a minus b. All right, so put down our two sets of parentheses for the right-hand side. And we're going to put a and b here and a and b here. Here's a, here's b. Just put it here, x2, and put it here as well. And the first has a plus and the second has a minus. You could switch the order. It could be minus plus, that doesn't matter. Let's look at number 2. Again, we want the instructions here will be factor, and we have a polynomial with two terms, so immediately we look for a difference of two squares. Is this something squared? Well, yes, it is. It's actually 2x squared. And is the second term something squared? Yes, it's actually 5y squared. So since it can be written as a difference of two squares, then we can use our difference of two squares formula. Again, just fill in with 2x and 5y. One with a plus, one with a minus. And number 3, again, look for a difference of two squares. 25z squared, well, that is 5z squared, and 49y squared, well, that's 7y squared. So as long as we can write it as a difference of two squares, then we can start filling in our parentheses with the 5z and the 7y. By the way, this factoring method is called factoring a difference of two squares. we're going to learn a total of 4 different factoring methods. The first one that we already learned was pulling out the greatest common factor, and the second one is factoring a difference of 2 squares. When we have a factoring problem, we won't be told which method to use, so first we'll always look for a greatest common factor and try to pull that out. And another thing that we'll look for if we have 2 terms and it's a subtraction is we'll see if we have a difference of 2 squares. So those are 2 things that we look for. Right, in number 4, we don't see a common factor, but it does look like the first term is something squared and the second one as well. So let's see. Let's fill these in. The first one is 7xz squared, and the second one is 6y squared. So it is a difference of 2 squares, so we can use our formula. In number 5, notice it says factor completely. That's sort of a hint that maybe we're going to use 2 methods. All right, it's not a difference of 2 squares. Neither 7 or 63, x cubed x, I don't see perfect squares here. However, we could pull out a common factor. All right, we can pull out 7 from both terms and also x. So when we pull out 7x, we're left with x squared, and here we're left with 9. And now here we do have a difference of 2 squares, x squared, and this is 3 squared. All right, so let's write that's x squared, and that's 3 squared. You don't really have to do this step if you don't want to. Don't forget to keep bringing down that 7x. That's part of the solution. So here we have the difference of 2 squares, x plus 3x minus 3. Number 6 also, factor completely. Okay, I do see a common factor of 5. Okay, we can pull out a 5. Let's see, x cubed, we can pull out x cubed. All right, so let's do that. That's it. All right, here from the first term we pulled out 5. We pulled out x cubed. We're left with y squared. We pulled out x cubed. We're left with, we pull out 5, factor 5 from 45, and we're left with factor 9. All right, now I see here we do have a difference of 2 squares. That's y squared minus 3 squared. So let's factor this as y plus 3, y minus 3. Again, don't forget to bring down that 5x squared. All right, and number 7, we want to factor completely. All right, here we have a 12 and a 75, so we can divide both by 3. All right, I think that's the largest number that goes into both. And x cubed, and here we have an x, so we can pull out x from both. All right, pull out 3 from 12, and we're left with factor 4. Pull out x from x cubed, and we're left with x squared. Pull out 3 from 75, and we're left with factor 25. We pulled out x, and we're left with y squared. Now this is a difference of 2 squares. Let's write it as a difference of 2 squares. 4x squared is 2x squared. 25y squared that's 5y squared. Okay, let's continue factoring. Just bring down the 3x, put down our 2 sets of parentheses, and fill in 2x 5y, 2x 5y, plus minus. Okay, now in this example, let's look at 98 and 32. I think the largest factor that we can pull out would be a just 2. All right, now let's look at x cubed and x. We can pull out x. Y and y cubed, we can pull out y. All right, 98. Pull out factor 2. We're left with factor 49. X cubed, pull out x, and we're left with x squared. Y came out. 32, pull out 2. We're left with 16. X is out, and we pulled out y from y cubed, and we're left with y squared. All right, both are perfect squares. Let me just write on top. This is 7x squared, and this is 4y squared. So let's factor now. Difference of 2 squares, and we have 7x plus 4y, 7x minus 4y.